Let's do a special case one, and then we'll do a little Pythagorean theorem as well. Or quadratic formula. Pythagorean theorem is the other one that scares math students. So we have, how about this? Go ahead and tell me where this crosses the x-axis, or where the zeros of that are.
Negative 16 and positive 16?
That's actually a really good guess. In that, the positive 16 would be correct if that wasn't there.
So just negative 16.
Well, negative 16, let's put it this way. Because this x is squared, if you plugged in a 16 right there, then that would be 16 times 16, which is like 264 or something, yeah. 256, I forget. It's way bigger than, it would be like 256 minus 16, which is like still not 0.
8.
Now you're thinking that's also very close to correct. That would be if this 2 right here was multiplied out front. But it's squared, meaning it's some number times itself equals 16 times itself.
4. Right?
A couple ways you can see that. I mean, you can just plug in a 4. What is 4 squared, or what's 4 times 4?
16.
16. 16 minus 16?
0.
0. Well, so we would find our 0 there. There's an algebraic way to solve this. You know, and we'll work on a little bit of this equation solving, where my goal is to find out what x is. So I want to kind of strip away anything that's not directly attached to this x and bring it to the other side. I know I want my equation to equal 0. Okay, and I don't want this 16 over here, so I can cancel out a 16 by adding 16. That's great. That's what's negative 16 plus 16?
0.
0. Okay, and then if I do something to one side,
do it
to the other side here. So 0 plus 16
16
equals x squared. That's 0. So now we see, okay, so 16 equals x squared. And then if you really want to stick to the algebra, how you find just what x is, because that's our end goal, what is x equal to? Well, I just take the square root of both sides. And the square root of x squared is pretty easy. What is it? How much have you worked with square roots before?
Not a lot.
Okay, so this is probably a step beyond. This is just for a full view of the algebraic way to solve this. You already got the answer. Square root is just the opposite of squaring. If you have something squared, you're asking that times itself is equal to what? And then when you take the square root of something, you're asking what number times itself equals this inside term. So the thinking just kind of goes backward. It's almost like multiplication versus division, or addition versus subtraction. Squaring versus square rooting. It just kind of undoes the thing you just did.
Yeah.
Moral of the story is it cancels out. The square root of something that's squared is just that something. And then the square root of 16, you already figured it out, didn't you?
4.
It was 4. Plus 4 works. Also, what is negative 4 times negative 4?
Negative 16.
That would be negative 4 times positive 4. What's a negative times a negative?
Positive.
That's exactly right. And if you want to see that here, this pen's going in the positive direction, yeah?
Yeah.
Okay. And then if I turn it around or make it negative, and then make it go in its backwards direction, so a double negative, which way is it traveling?
Positive.
Positive overall. It's just like doing a 360 on skis, a double negative.
Yeah.
Or more like a 180, switch 180, and now you're going forward again. Moral of the story is plus 4 works, because 4 times 4 is 16. Also, minus 4 works, because negative 4 times negative 4 is also 16. And if you want to see what this parabola looks like, go ahead and plug it into GeoGebra. X squared minus 16. There you go. It was just x squared minus 16, I think. Cool. And And then I don't know why our blue graph is still there. I mean our green graph. Okay, it went away. There we go. So where does that cross?
-4 and 4.
Right. It's a parabola. It's either a big smiley or a big frowny. So it's definitely going to cross at 2 places. If you're ever doing a problem and your answer is just 1 plus 4, then just think to yourself, okay, am I missing something? Oh, wait, this one's can have a positive or a negative answer because of this. One last way to solve this, I'll just show you really quick. X squared minus 16 is actually to look at it more like this. You're going to use the same exact technique that you were using before.
Yeah.
Okay. What number multiplies to negative 16? What 2 numbers multiply to negative 16, but then add to 0?
4 and 4.
4 and 4, negative 4. Okay, so those 2 numbers multiply to negative 16 and add to 0. Therefore, your factored form is definitely the same thing you've been saying here. Not bad, huh? Cool. Whenever you see a problem of this form, without the middle term, without anything with an x in there, the answer is just always going to be plus or minus the square root of this number here. Put it into those 2 spots. Okay, so like super quickly, now that you've got that on, let's see how fast you can do this one. See if you can apply the same exact pattern to solve that one.
Oh, wait, yeah.
2 numbers that multiply to 25 and add to 0.
I don't know.
Let's come back here. In this case, we were looking for 2 numbers that multiplied to negative 16
Oh, 5
and
times
added
2
to
is
0.
10.
There you go. I think you were thinking of 5 squared.
Yeah.
It tripped you up a little.
So then just negative.
Boom. No problem, right? All right, let's do, like, these problems are so fast that I'm just going to make you do one more.
Okay.
Just so it just burned in the memory here.
Wait, is it added or subtracted? Or is it it's multiplication?
Cool. And just for comprehension's sake, x times x is x squared. 10 times negative 10.
Negative 100.
Negative 100. What's 10 times x?
10x.
And then what's negative 10 times x?
Negative 10x.
So what is negative 10x here multiplied by, or added to positive 10x here?
50. Negative 50. No. 0.
0, right? I asked it in a confusing way, but it's 0, right? You have the same positive amount of x's as you have negative amount. Smash them together, it makes nothing, and that's why there's no middle term here.
Yeah.
Okay. Same thinking as these problems, though. You just have a 0, which makes your life easy.
Yeah.
Okay. Not bad, huh? That's like 8 problems we've done already today.